we're going to take a look at distance and midpoint in the complex plane. All right, so find the distance between these two complex numbers. To find the distance, you're going to use your prior knowledge, but instead of x, you're using the real numbers, and instead of y, you're using the imaginary. So x-axis is your real numbers, y-axis is imaginary. All right, so this is the distance formula from your previous knowledge. Okay, so we're going to go ahead and apply that. So first, plot the complex numbers. So you're plotting 3 plus 2i. Then plot -5 plus 4y. Okay, then join the 2 points. Then find the distance, and now you can use the Pythagorean theorem. So make an x and then make a y. And then count those boxes at 8, or count the distance on the x-axis. And the height is 2, so count the boxes. All right, Pythagoras theorem says the square root of 8 squared plus 2 squared, which is going to be the square root of 68, which is approximately 8.25. So that's one method. Okay, we're going to look at the second method is just plugging it into the distance formula. So write down the distance formula with blanks. So d is equal to the square root of parentheses blank minus blank close parenthesis squared plus parentheses minus close parenthesis squared. All right, so again, the real part is the x's. So the real numbers are 3 and -5. And you're going to substitute the second one minus the first one. So the second one is -5 minus 3. And then you're going to do the imaginary part, which are the y values. So the second number, 4, minus the first number, 2. Then you're going to just put that right into a calculator, but I'm just going to do it by hand. That's going to give me -8 squared plus 2 squared, which simplifies to 64 plus 6 plus 4, which is going to give me, again, the square root of 68, just like before, which is approximately 8.25. Okay, so this you've done before. Okay, you should have seen that before. Now we're going to apply complex. How do I do distance in complex? So what you do is you subtract the two complex numbers from each other. And honestly, the order does not matter. So you remember, you subtract the real part, 3 minus -5, and then you subtract the imaginary part. So plus 2i minus 4i. And that's going to give me 8 plus -2i, which is going to, of course, the positive and the negative is going to be a negative. So 8 minus 2i. All right, then you find the modulus of that number. So the square root of 8 squared plus -2 squared, which is again going to give a square root of 68, which is approximately 8.25. All right, so go ahead and try example 2 on your own. This is a listening check. Put a box around example 2. Box example 2. So I'm going to take a look at midpoint in the complex. You're going to actually remember this chair. Midpoint, midpoint, what do you do? Add them together and divide by 2. Midpoint, midpoint, what do you do? Add them together and divide by 2. So that's what you're going to do. You're going to add the real numbers and divide them by 2. So I'm going to line them up above each other. I'm going to add the real numbers. So it's going to give me -5 plus 3 is going to give me -2. Then I'm going to add the imaginary numbers. 2i plus 4i is going to give me 6i. Then divide by 2. So I'm going to add first, then divide by 2. It's going to give me -1 plus 3i. So again, midpoint, midpoint, what do you do? Add them together and divide by 2. Now go ahead and try example 2. Midpoint, midpoint, what do you do? Add them together and divide by 2. Let's practice.